Okay. My topic will be a little bit lighter and like more surface level than previous one, but I think it will be still quite interesting. It's interesting for me. So, like I said before, I'm Lumír. I'm building two chains on Polkadot and Kusama. And today I want to speak with you about account abstraction, which I think is quite related to the proxies previous topic. So, as you know, currently, to do any transaction on the Ethereum, you basically have to interact with it with external owned account, basically, like some private key that has like some Ether in the storage, and you can use it to pay gas, right? So for example, you will call that proxy and like interact with MakerDAO or whatever. Like you always have to have account like that. So basically, Ether is cool with like you can change whatever, like it's basically you can program what is executed on the chain, but you cannot really program currently like how you validate the transactions, right? So like we have this fixed EOA thing, and like you always interact with it the same way. The transactions are completely the same, and it's like one of the current limitations. So like obviously EOAs are really simple, and like they are not really secure if you want to manage funds of DAO or some company. So you are using multi-sigs and like different smart contract wallets where you can change who can like delegate the funds, where you can like control stuff like that, where you have like basic contract wallet things. But like still, if you had contract wallet, if you have the multi-sig or some delegated wallet, you still need to have some account that has it's externally owned and has the gas money to pay for it. So account abstraction is trying to like resolve this issue. So basically, the contract wallets can become like first-class citizens, and ultimately, like you can get rid of like externally owned accounts at all. Like you can just use your contract wallets. So why you would need to do that, right? Because like I said before, like you have different like multi-sig schemes. You can change like what kind of signature are you using, because right now, like if you are using external owned wallet, you only can use like ecliptic curve of Ether, and like that's it. Like you cannot use any different like signing scheme, so you are stuck with it. But like with smart contract wallet or account extract, like you can use whatever like signature you want, right? You can use BLS signatures, or even like the signatures Polkadot uses that I cannot remember how it's called. But so it has like a lot of advantages like that. Like, and all the advantages of like normal smart contract wallet, like social recovery, and you can have different multi-sigs. And then we get to even like more interesting use cases for account abstraction, where you can actually like can say, okay, maybe I don't want to pay with Ether for my gas. I maybe want to pay like with DAI for it, or whatever else I'm using in my protocol, right? So if I am like dApp developer and I have native token, like now if I want somebody to interact with my dApp, I have to like somehow onboard them, not with my own tokens, but even like but with Ether as well, so they can actually pay for the transactions. And this is like a pretty big UX hurdle for a lot of new users, so they have to like tackle this. And like for protocols, we always try to find a way how we can basically onboard I would say like normies and like the crypto beginners easier to our dApps, especially when we're making games. We were really trying to, like mobile games, you can imagine, like on mobile game you don't have any MetaMask, and like you don't really have Trezor connected to it. You don't want to, like every like game move that you do, you don't want to like sign the transaction, for example. right? So we always try to like how we can make it better and simpler, and not just like the interaction with the game, so you don't have to like basically read whatever bytecode you are signing, but you don't have to care about like, okay, now I want to start playing with this game, but I first need to go to some exchange and buy Ether and then transfer it to my wallet and stuff like that. We wanted always to onboard the people through our like company. So we were like okay with like paying, for example, gas for them. Like if they are beginners and they are just getting into the game, we want to onboard them, like we will sponsor the gas for them. So this is the way how you can do it, like through smart contract wallets. You can pay for gas of the users. So you can effectively have like schemes like that. And also what is interesting, you can start like interacting with wallet that is maybe that doesn't have like anything, like you just like make it from the thin air, and you don't have to link it to the Kraken to get your Ether and then withdraw Tornado Cash. You can directly withdraw with Tornado Cash and create effectively a new wallet. Yeah, this is account abstractions allows you to do something like this. So you can basically submit transaction for the free, you can say, because the transaction itself is validated. Okay, if like the Tornado Cash withdrawal goes through, I will get like I will get portion of it, for example, right? So like you are still paying for the transaction, but you don't have to necessarily pay, like you don't have to have it upfront in your wallet, right? So this allows you to, for example, create new accounts for Tornado Cash or withdraw from bridges, claim from some vesting schemes, stuff like that. So it's really useful. And I was really like excited when basically Vitalik was pushing this. And like original idea was in ERC or EIP that was directly part of the protocol. So guys were saying, okay, we will change how Solidity works, how the protocol works, how the signing transactions is done, and we will integrate this functionality into it. But because the Ether is like the big boat and it turns very slowly, it's like not really, like they were like quickly seeing like this is never going to happen. Like at least not if we don't have like some traction behind this idea, even if it's like really cool idea, right? So they had to come up with like compromise, I would say, which is like the, like I guess year-old EIP 4337, and it basically tries to achieve the same thing, but like with no protocol change. So how it actually does it is, if you are familiar with like gas station network, which is protocol basically built that allows you to do stuff like sponsor somebody's transactions. Like basically you can create these meta transactions and relayers will sign them and pay for gas, and like it will happen whatever you signed, it will happen. Like it's like just this use case basically. So this is like improved version of it, and it's actually built by the same guys as they did the OpenGSN, and it was also audited by OpenZeppelin. So like this scheme basically has few parts interacting with it. So you obviously need the wallets, which are the like smart contract wallets where the like is the special functionality in, that can be the multisig or the smart contract wallet with different schema, stuff like that. And and these wallets have two parts. Like they have the execution part, which is like obvious, which is like normal smart contract part, but they also have like validation part. So validation part is added there, so like bundlers, which basically take these meta transactions and try to bundle them and submit it to the like real mempool can first validate, okay, this transaction will go through, so they are not wasting gas, and they can also validate, okay, somebody will pay me for this gas if I like bundle it and submit it. So users actually use these wallets, sign the transactions, and like distribute it in separate mempool from like the regular mempool of the Ether, where like bundlers are listening and they are bundling these transactions and sending them to the chain. So, and this role of bundler would be like normally, I guess, miner or validator. Like if the bundler, like if all this functionality, if ERC-4337, the initial idea would come through, like it would be done by the actual like block producer, by the validators. So this is always the future, that bundlers will be like the block producers. So, but like now it's not part of the protocol. They are just like any other like, yeah, it can be basically anyone. Like even you can bundle your own, I guess, meta transaction, right? But it doesn't make much sense. And there is like additional role of paymasters, which are separated from the bundlers, and they are like the just role, which was like filled by GSN before. This is the role that like actually pays for the gas. So the wallet itself doesn't have to pay for the gas. It can be some paymaster. And this enables, for example, payment for gas with different currency. Because paymaster will pay in Ether for the transaction, but then when a transaction goes through, they will get DAI from you. So they will like make their money back thanks to that. And there is like entry point contract, which is like central entity which everybody interacts with, or like basically calls any other contracts in this scheme. So there is diagram actually how it works. So first bundler like looks into the mempool, picks transactions, like picks whatever they want to bundle in. Like in this case, there is just like one transaction, right? So it's a really small bundle. So first, they will verify signature of the contract and verify that like you can basically execute it. Obviously, this whole process is like just one transaction. So they can execute it and like try to execute it, like just dry run it and see if it can go through. So, and this is the process of the dry run, or like the run actually will be the same. But they will first like call the check on the wallet contract, and this is, and the check contract itself, like, or the check portion of the contract is optimized, and it has actually limited opcodes what you can do in the check. So you are not spending too much gas on this check, and you cannot like DDoS thanks to like super expensive check that would change. Because like you can imagine, you can flood the chain with your, or like not the chain, like the second mempool with your transactions that will all be invalid in the next block. So obviously in this block check will pass, but like when the bundler will send it out to the blockchain, then on-chain it will fail. So these situations, they are trying to prevent those by like limiting what you can actually do in the check. So you cannot do schemes like that. So that's the first part, like check has to go through. Then there is the interaction with the paymaster that will actually pay for the transaction if paymaster is included. So, and there is important thing to note that paymasters are staked. So, yeah, this is like way how you can prevent them like flooding bundlers with like work that they are not paid. Because even if bundlers are not spending any gas or fees, you have to consider they have to always like take these transactions from the pool and try to validate them and bundle them. So like they have to be covered by checking function of the paymaster that actually they can pay, And if everything goes through, if the wallet contract is okay, if the paymaster is okay, then finally we will execute whatever was signed and whatever can the wallet do. And finally, the wallet, finally there is optional part for paymaster to call something to get their money back. So they can maybe withdraw something from your account or whatever is part of your setup with the paymaster. So this is the convoluted way how you can do all this without changing the ETH itself, right? So you still need EOA. EOA is the bundler, but the users actually just can sign the transactions, send it into not to the regular mempool, but to the like bundles mempool, and get it processed, I would say. So this solution of account abstraction is already audited and deployed on, like, I guess, any L1, L2, and if it's not, you can always deploy it yourself. Like, the biggest issue always with these things are, like, you have to have some network of the bundlers and paymasters that are actually willing to, like you need ecosystem around this, like of the wallets that are compatible with it. You need like people that are bundling it, that are basically running the network, and yeah, people developing on it. So definitely what you can do is to build something, build your like smart contract wallet that is compatible with this. So, and that way we can only kill EOA, but I guess not before the merge. I don't know how I am on the time, but this is the part how the account abstraction is solved on Ether. And now, because I'm mostly working lately on Polkadot, I would like to show you how we do things a little bit differently. So this is Polkadot network. For those not familiar, we will like go over the parts and like explain it a little bit. So basically, Polkadot is a relay chain, which is, you can say, like Ether's beacon chain, and there are like attached these little parachains around it. Do you have a question? No. Oh, okay. And yeah, I just wanted to pause. Sorry. So there is the dance of the like parachains around it, and these like baguettes or like whatever pills are actually validators of the relay chain, because the Polkadot relay chain is a delegated proof of stake. So they have like hundreds and hundreds of validators, and these validators like over time take turns, and they are actually not just validating blocks of the relay chain, but they are also validating blocks of these parachains. And these parachains, they are their own, you can say, sidechains, or in Ether lingo, it would be shards, I would say. And they have their own block producers, which are collators. So, and they have their own runtime. Basically, they have their own like change, like state change function, which is like executed here, and also executed by the validator. So actually, how the parachain block is produced, the users on the parachain sign transaction, send it to the parachain mempool. Collators will pick it up, create block from it, and they will submit it to the nearest validator that they have just assigned to. And validator actually runs like check function that, like, validator is not connected to the parachain in any way. They are just like getting these like blocks from the collators and taking basically the validation function, which is stored on the relay chain, paired to that parachain, and they are checking if the block produced is valid. So that way, like the validators can like one block validate one parachain, next block they are validating different parachain. So they are not like affiliated to the parachains in any way, but they can still fulfill their role. And they are actually what is like producing the blocks of the parachains and providing the security of the parachains. Collators are more like the composers of the block, you can say, right? Or they are just like keeping up with the mempool and picking blocks, like creating blocks from it. So when you actually build the parachain, which is like the shard interacting in the network, you can change almost everything, like almost everything, like including the peer-to-peer networking, RPC method, consensus scheme, and obviously the biggest and most important is the WASM runtime itself, which is the part that is actually like governing how you can change the state. And this part is also stored on the relay chain, so validators can check it. But what is important thing is that you can change really anything. So you can change the consensus part. So you can say, like, in your parachain, okay, I will not accept these like parameters in my transaction. My transaction can be built completely differently, right? I can have different signing scheme. I can have different rules. What I accept, I don't have to have any fees. I can like you can basically move the checking part of the transaction to the consensus layer. So the collators can serve as the bundlers, right? They are checking the one-man pool, and thanks to the validation that is stored in the consensus, they can include only valid transactions. So this is obviously like any parachains. Like parachains are typically like focused on some use case. You have parachain for the lending, you have parachain for swapping, you have parachain where is the bridge, you have parachain where is the stablecoin, stuff like that, right? So every parachain tries to modify how they work based on their use case. So for example, one of the parachains, one of the parachain has EVM, smart contracts, and they are like basically more of the Ether sidechain. So they, as the like default signing schema, use the same as Ether uses, right? So you as the user can go from Ether and use the same MetaMask, but now you are interactive with the parachain. You don't even know it, right? So what actually, yeah, I can talk about this maybe a little bit after, but point is, parachains are in control of the protocol itself. So if you need some special signing schema, you can just change it, right? You can add the new functionality into it. You don't have to make sure, as Ether does, okay, everybody is okay with this change, like we can have this on the protocol layer, like nobody is against it. In the parachain world, like just the focused group that is managing the DAO can decide, okay, this makes sense for our protocol, so we will do it. So what we are actually handling as the problems in the parachain world is that like every little shard uses actually their own native token, like their protocol token, as their transaction fee token. So if you want to do something with lending protocol, you have to use the lending protocol token to pay for it, right? So this gets complicated really quickly. That's why most of the parachains actually, and our parachain as well, support some way of like accepting payment in more currencies. And they will just accept payment in other parachains currency, and then they will swap it later or just gather it, like depends on their strategy, or they don't accept it. But like they will probably accept more than like just one currency to pay for the transactions. So this is really important because imagine if you want to send the token from one parachain to another, you have to pay somehow to receive that token on that second parachain, right? So if that second parachain wouldn't accept the token you are sending, I don't know, like you need to send basically two tokens, like one token for the gas and second token for that you actually want to send. But this way, you can just subtract portion of the transfer and keep it as a fee. So it's much more simpler, and like users don't have to really deal with it. And what is nice about our users, they can just swap like whatever currency they want to pay with, like how they like. If they run out of our tokens, they can swap for different ones, and we will accept that as the payment for the fees, because we don't have problem with it as the swapping platform, obviously, because it's advantageous for us, but other platforms are actually using us to like get whatever they are accumulating in their treasury actually. Because like, again, every parachain is not just their own token, they are their own DAO. Like every parachain has their own treasury and organization behind them. So also you need to link it somehow, usually if you go into the parachain world. So for example, like you cannot create the parachain wallet from the ETH wallet. So you have to somehow like link these two. And how you do that if you don't have like any tokens in our platform yet? So we will allow you to just call claim without any fee. Like you will just sign it, and because we validated, okay, you will actually claim something, and we will take part of the claim as the fee, you can call the claim, right? So in our case, the validation function is moved to the consensus layer. And you can see, well, yeah, you can do all sorts of stuff, but yeah, mostly it's on specific use case. So we don't have to deal with problems that Ether deals with, because Ether's solution for the abstracted accounts has to work for everybody on the system, and they can always deploy arbitrary code to it and break it. In our case, it's much more restricted what you can actually upload as the user to code to the chain, right? So yeah, we don't deal with because we are just like subset of the network. Like we don't have to deal with rest of the issues of the whole network. Do you have 2 minutes? Okay, I'm actually ended. So if you have any more questions, yeah. Did somebody understood me?
I have stupid question about Polkadot. So you have the relay chain and you have like the parachains. Mm-hmm. So when you deploy the app, where the fuck is the app actually running? You need to deploy to parachain, or you can actually deploy
what you are deploying? You want to deploy
whatever. Let's say you're just swapping something or something stupid, like which area?
You are creating like your own app.
Yeah.
With the contracts and the front end as well.
When you deploy your contract to which chain?
You will target one of the parachains. Like relay chain is just, for us, it's just the security provider. They are not providing any other functionality than that.
Okay, so basically in Polkadot, like nothing is Mrkva relay chain, there's no smart contracts, no nothing,
everything is delegated to the parachain.
Okay, cool, thanks.
So you will pick the parachain that mostly suits your needs and deploy it on there. Or you will create your own parachain.
Yeah, but for that you need to do this auction and get the slot and it gets complicated.
Yeah, it's complicated, but it's one of the options.
Okay. So actually somebody does it, like someone do like, let's say like if you want to run some bigger app on like...
Yes, definitely. If you want to, like, if you have big project, for example, if you want to build stablecoin, it's worth it to run the whole parachain in this case.
Okay, cool, thanks.
Yeah, or if you have special use case that like, if you have specific use case where you want to change how the consensus works. For example, you want to have chain where you are like reordering transactions in the block. You have special order to match, for example, trades against each other. Like you have some use for this. Like you cannot do it without making your own parachain, right? Polkadot allows you to create your own parachain and implement this functionality, but you don't have to deal with like, okay, where do I find like hundreds of millions of dollars that of the stake liquidity that will like validate my chain, right? You don't have to deal with it because you are sharing the validators from the Polkadot network.
Yeah, that's actually super cool because if you want to change the consensus like somewhere else, you're basically fucked, you cannot do it.
Yes, try to convince Ether to change the protocol, how it works, right? But if you are owning the protocol, you can change it.
Huh. It's actually super cool. I never thought it.
Regarding the account abstraction, what's the difference between this, what you show, and the normal implementation of the meta transactions?
What's this normal implementation of meta transactions?
It looks really similar, I would say.
Yeah, it's like I said, it's like next generation gas network basically. But it's trying to mimic basically the following EIP or like the older EIP to basically test this and hopefully push it to the protocol level. So it's actually extended GSN. It's not just meta transaction because you have you have different API basically.
What?
API.
Oh, okay. For the backend of what?
Mostly for the like smart contract part, like the interfaces of the entry point, okay. Interfaces of the paymaster, how paymaster works, like the whole like this whole system. It's like much more general than just gas station network. So you can do more cool stuff. Like biggest problem with it is that like it still requires like setup like gas station network. Like it's not built into the contract to the protocol. So it's like kinda complicated to create, for example, your own wallet contract, right? And you have to rely on like a functioning network of bundlers to get it.
I will ask here, do you guys know the meta transactions? Or is here anyone who doesn't know the meta transactions? A few. Yeah, the key point here and also for the meta transactions is that you have someone else who is paying for your transaction. That's with handling ETH.
No. This is different.
I know, but in general.
The bundler, right?
In general.
No, in this case it's paymaster. Generally, meta transaction means somebody else is your paymaster. Yeah. But I didn't actually show the other way around. You actually can pay as your wallet itself. You don't have to have like the bundler actually doesn't have to pay for a transaction. Like it will get it back immediately, right? So for example, if you are withdrawing from the Tornado cache, the bundler will get it immediately in this one block, right? So this is how it's different.
I was more coming.
This wasn't like you weren't able to do this with gas station network, I would say.
So this bundler, is it something that already exists in the protocol, or it's some new role that needs to be?
No, this is not part of the protocol. It's just like some like coordination of the smart contracts and the bots that are running this on top of the current Ether protocol.
So in order to implement this, we would need someone to actually deploy this solution. And
this is already deployed. Like only thing you need to do is to create a wallet contract and start using it.
Yeah, I'm just trying to understand whether this bundler has potential issues.
That's not that difference which I was asking for. If you use the meta transactions as such, or you want to implement them, besides the contract, you actually had to implement also bots or basically some backend code off-chain code which would be collecting those transactions, doing the bundling, and interacting with the...
Yeah, this is definitely, it has the off-chain part as well. Because it has basically second mempool, which is like one of the biggest issues of this solution, because obviously with second mempool you have like opportunity for some censorship and stuff like that. So
Well, I understood that in this case, the standard itself actually they created like a way for the economical players to participate on being the bundlers and so on. Is this correct?
yes, and mainly the unified API, how you can create a wallet that can interact with this, right? So they basically this is the most important thing that should also be compatible with like if this makes it to the like protocol level, the wallets should be like compatible still with it. So if you are using this or you will use the protocol solution, it should still work. So this is basically, you can think about it as like canary network or beta version, and like Ether validating, okay, this is something, it makes sense to integrate directly on the protocol level before they do it. So
just to give the example on the meta transactions and also potentially using of this, when you transfer like USDC or DAI, which you mentioned today, it's ERC-20 token. When you transfer those, you have to have a ETH for gas. In whatever layer, on the layer 1 or any layer 2, you have to have the ETH for gas or an actual token. In this case, and the meta transaction, you don't need to have that. That's what you can already experience with the CoSwap, for instance, that they are like paying for that transaction, but they withdraw it value-wise from your assets which you are handling with them.
yeah, but they have custom solution that is like they have their own mempool, their own like off-chain part, how they're handling it. So this is like something that should work for anyone interacting with the Ether.
It's more standardized and can become more decentralized, I would say, right?
Yeah, it's currently like ERC-4337, and the original idea comes from ERC-2938, which was targeting like actually change in Solidity as well. So you would be able to define, okay, this is the smart contract wallet, so it has like it has different like functions that it can implement and stuff like that. So yeah, but like this is 2 years old, this is 1 year old, so it's not getting like
So 5 more years and we're
but like you have to imagine, like this was I guess it's just 3 months like this is deployed just 3 months on the L1, so it was audited like 3 months ago, I guess. So it's not that used yet, so we need definitely more builders. Like one of the things I have on my hack list is definitely to create the wallet which has signing mechanism from Polkadot actually. So our users can go on that like EVM parachain and use their own wallet. They don't have to create like new MetaMask wallet. They can like already, they have wallet from our network, so they can just use that on their network. All right. So so it enables some stuff for us as well. Yeah. Any more questions? Or we can move to another break.